We got somebody else. Yeah. We'll quickly kick off today's call. Today that we are going through the chapter 6, which is like object and data structure, and there are a few things that we will cover. What is some of the data structures and data object and the symmetry, the law of Demeter, and data transfer objects. One of the things just want to highlight is like this data structure is not the data structure like you have the collections like the list, the arrays and map. It doesn't talk about that data structure. It's just how do you encapsulate a data within a object. So there's a slight difference. So just to ensure we don't have confusion around it, so that's why I thought I'll call this out at the beginning. Uh, One of the key thing is about the data abstractions. Uh, So one of the key principles, if you know, would be like whenever there's a class, you try to keep the member variables private, and you also want to ensure that you don't give access to all those member variables. Like you add getters and setters, which is like one of the tried and tested approach to use the class, but then we should be careful about doing that because what that would do is like anybody and everybody can go and update that class. Instead of doing that, what a better practice would be is to expose certain interface for that particular class. So for example, you expose certain public methods which would kind of which will be doing certain actions and giving you the results back. So that's one of a better practice. Having said that, you still need those classes which have purely data, so which you can kind of use the getters and setters for it. So yeah, so one of the things that is anyways a complete no-no is that you should not make it public. If this member variables, the reason is that if you make it public, anybody can once you create a rectangle object, you can anybody can go and invoke it. Any other class can basically use it, saying rectangle dot length. Uh,
And what's the risk that results from other objects being able to invoke it? Could they possibly, really mess up an instantiation of the object or something? Or
yeah, so it will not mess up the instantiation. It would What would happen with this kind of a code is that anybody and everybody can go and update the value in the class, which means that if there are like 100 classes, you don't know like the value is getting updated. There could be a scenario where value might be updated in 10 different, maybe two different classes at the same time, and it will and you don't have any control over it as to what's happening to that particular object at any point of time. So you don't want to do that. What you would try to do is what you would try to do is you try to keep it private, so that there is only why a certain method is getting updated, and then there's some control around it. Even if you use a simple getter and setter, it's not a very good control. But yeah, I mean it will at least give some kind of an interface, some kind of a protection, rather than this is like a zero protection on it. Anybody can update it. I mean, one way to probably do it is like we kind of do it final, uh, which is basically then you'll have to kind of, if you do it final, then anybody can it becomes immutable, and then like somebody did as a constructor. then yeah, you cannot change it. Like once it gets instantiated, it cannot change it. So that's one way of doing it. But you don't you want if you want it to be immutable, you it to and only the uh, you're doing it via certain interfaces, specific. So that's one of the thing. And yes, so for example, another thing was only to expose interface. So is basically like for a particular class, your method can be an interface. So instead of once a rectangle is instantiated, you kind of expose only length and breadth, which would kind of no, sorry, you only expose this method called calculate area. So anybody who wants to get the calculate the area, they can kind of use only this method, and somebody goes and changes this variable to height, length, convert it into, they just rename it to height. Whatever the calling functions, they don't need to. I don't know if I spelled height right. The calling functions or the calling methods, they will not need to know that the member variable name has changed, and they do not have to do an update. What they are only talking about is a calculate area. So for them, the working of the class is transparent. They don't know what's happening inside the class. Similarly for the logic, right? If inside I've changed the logic, they don't care about what the logic is. They just ensure that whatever this particular calculate area method is doing it correctly or not. So that's another advantage of exposing only the interface and working through it. Yeah. Any thoughts?
So in real world application, uh, an API, or maybe I write some code that calls an API. That's an example of it, right? They're only exposing to me those methods that they want me to pull from to get the area of this rectangle, but they don't want me to know the details of what defines this
Yes.
rectangle or how. Okay, and that's
Yeah.
kind of the point, right? So in a way, it's like we're keeping our secret sauce hidden, but still serving you the meal.
Yeah.
Is that okay? Okay.
Yeah. So it's the same concept that gets expanded out when you talk about API.
Okay.
And so the next one is this. He talks about this data and object antisymmetry. So now I'll just clarify what data, when he means by data, is this kind of a class is more of a data class, which doesn't have any business logic. And I put this calculate area, but if you ignore this calculate area, it just a getter and setter. If I just add getter and setter, it just becomes a data class. And then you have a thing called this kind of a thing where you have operations that are there. Those are where you will have all the methods, lot of methods around it. So it will look like more of a, it may or may not have some private variables, but the whole point of this particular class is it will have some business logic to it. So uh, yeah. So you have one class which has got a lot of business logic, and then these classes which are uh, uh, which have only data to it, and that is the one of the separation of concerns that we talk about. Is like you need to have two types of classes. One classes which have only data, and the other one which will have your business logic. And that's we try to keep. I mean, the whole idea is that we need to keep both of these separate. Now, if you are looking at Spring Boot, um, in Spring Boot, they already have this convention of service, and then they have controller, and then they have repository. So a repository is where your all the data related data models, not the data model, but the connectivity to the database sits, connectivity to the database or connectivity to an external API. Service is where your business logic resides, and controller is your which exposes the endpoint for you. So similarly, and then we also do it in model. Like this is like one of the way is being done in Spring. It's like we would create objects, which this doesn't have any business logic. It will only have the variables, I mean the private members, so that it can directly work with the database, and all the business logic will be present in these service classes, where we'll have a lot of methods doing different things on using that those models. So the models, they don't change. Even if they change, they should change in a way that is non-breaking. uh, you, Generally you don't want to, once a particular model is there, you'll generally not delete a model, because if it deletes a particular column, there is a implication around it, like in terms of you code break at a lot of points, and then yeah, if you're using that continuous integration, it becomes a challenge with continuous integration and deployment if you break the model. So you try to make the code non-breaking. Yeah, and so the key thing that Robert C. Martin talks about is this: procedural code makes it hard for creating data structures. So going back to this shape operation, where there's some certain methods like get shape, print shapes, find shape with max area. So I cannot create a data structure. If I have to create a data structure, for example, if a new data structure is created, say pentagon, and I need a I'm using a get shape, so I might be using like all this. What would happen is, anytime there's another new shape that comes in, I need to go and update all these methods that are there. So that's a problem in this kind of a thing. But then there's a new business rule. The thing is, I just go and add a business rule below this one thing. There's another method saying whatever the business rule is, and then you just add that particular method. So that's a it's a procedural way of doing it. But then this has this benefit that you don't need to change all the classes that is dependent on this. So for example, circles, rectangles, whatever, pentagon, hexagon, whatever comes in, it doesn't depend on that thing. The business logic will remain the same. You can kind of add more things. But on the flip side, if you're using this object oriented thing, like you have this shape as an interface, and then you have a different method. You can kind of go on adding more interfaces. I mean, if you have an interface, if you implement an interface, then you have to go and update all the. If you're adding methods, you need to update it. But if there's no method in it, if it's a pure data class, then you don't need to update it. You just can create it that particular class and then keep it as is. So that's a little bit of change. So if you want to add a new function in oops code, like for example, as I talked about calculator, if I want to add more classes in more methods in this particular interface, I need to go and update all the shapes one after the other. So that's makes it difficult. And but procedural code makes it hard for creating data structures. So yeah, if I have to add a hexagon and other things, if there's a shape operation, then I need to go and update all the methods and to revisit all the methods and see whether the new hexagon or octagon, I need to update any of these methods again and again. So that's the thing, that if you have a procedural code, it makes hard for creating data structure, and then if there's a OOP code, it makes it hard to add new functions. Uh, yeah. Any thoughts?
How can we avoid this?
It's not avoiding. It is more of a, how do you want to put um, how do you want to put this data segregation, right, or your separation of concern. So um, you will have pieces of code like this operation where all the logic will reside. Like you do this, you take rectangle, you take circle, and then you do something with it and then return something back, or you go and update a rectangle something. So those all those things, or you update a circle and everything, all those things comes in those scenarios. You have to write this particular piece of thing which will we interact interfacing with something else, many other things, and getting things done. And these are the models where you are only talking about what those particular models require. So yeah, if it is like a pentagon, you need 5 member variables and so on. So, but it's a choice that you need to take. It's a decision that you as a developer kind of make whether a particular method, for example, this calculate area, I could easily put it in shape operation, and then I can do this. If shape instance of circle, then you do pi r square rectangle length. I can easily do that. But then I find that okay, in this scenario, there are a lot of if and else condition coming in. So I should think about a better way of doing it. In that scenario, I put it in the interface. So then that becomes cleaner. Whenever a new shape comes in, I just need to implement that method. That's it. And then I can call a particular. Uh, I can kind of make it a very um, like I can do something like this. Not this one. Yeah, I can do like this. Uh, I mean, this is a simpler one that if you want to calculate area, and then so yeah, so this is thing that you can kind of just do a calculate area and pass a shape, and then it will just call shape dot calculate area. So at that point of time, the compiler will whatever the shape has been passed, whether it's a rectangle or circle, it will just go and get the area for you based upon the instance of that object. So this makes the code easier. Now, if the other option I would have to do is like if shape instance of circle called circle dot calculate area, and so on. If shape instance of rectangle calculate return rectangle dot calculate area, and so on and so forth. So this kind of a approach makes it simpler. And like obviously we are just doing with a very simple example, so that's why it might not seem a big deal, but yeah, because the code will you'll have more models, and then this will become an easier approach in that scenario. But this is a decision that you as a developer take. Where do you want to put your method in, whether you want it in the object, or whether you want to put it in this kind of an operation class, or a procedural type of code. And then that decision is driven from this particular thing, that if whether they'll so if you think about it, are there going to be more new shapes that are coming in from your business perspective? If yes, then you would want to put it in the oops part of it. Or is it just like a one-off thing, and there will be more, this is like a more of a business rule that business wants to do this, and then there's another feature that comes in, you want to do something else with this shapes, then you kind of put it in that procedural part. So it's a decision that uh, you kind of evaluate where do you want to put it in.
Effort and complexity over time.
Yeah, that's correct. Yeah.
So with OOP, there you have to add new functions. The methods are in the object, so that's why it can be difficult, because every time you create a new shape, which would be an object, then you also have to put the method of like get this shape, and so every shape has its
Yeah.
calculate area or something like that. Whereas in procedural, you only have one calculate area function.
Yep.
Okay. So you're it's like the kind of repeating yourself. How do you want to repeat yourself?
Correct.
Okay.
Yeah, so that's why that you need to have a little bit of context about the business, how things are going to shape up in the immediate future.
Right.
Yeah, and For example, like I work in a telecom organization, and we have only two types of product. That is either it's a mobile product or it's a broadband product.
Mhm.
So then I know that if I put it in that interface, it's not going to increase beyond it. So if I have a interface saying services, and then
Mhm.
I say there are two products, say one is mobile and the other one is broadband. I
Mhm.
don't need to, because if I add new method, I just have to put it in the two classes. So in that scenario, I can take a decision. You know what? I can, if this is a common thing like calculate bill, it's a common method for both of them. Then I can put it in the interface and implement it, because the business logic of the bill calculation for a mobile plan and a broadband plan will be different. So in that scenario, that would fall in this OOP uh, framework pretty easily. Yeah,
Because you only have those two objects.
that's correct. Yeah,
Yeah.
yeah. Right. Any other thought? All right. We'll go to the next bit. Um, so is law of Demeter. So yeah, it's one of the yeah, it's a law that I think you would have been already exposed with. It's just that what it says that you should each unit should only have limited knowledge about other units closely related to the unit. So, and in simpler terms, an object should only interact with its immediate neighbors and should not have knowledge about the internal workings or dependencies of object further away. And the whole idea is to minimize the ripple effect of changes, meaning that modification to one part of the system should not require changes to another part of the system or unrelated part of it. So, yeah, so this again goes back to the principles of, like, you want to ensure that whatever the change that you do is more local to that particular thing, unless it's a broader change across the entire source code. But what you try to do is you try to keep the code modular and simple, so that, like, for a particular class has only access to like one other class or two other class kind of a thing. So the lesser dependencies you have from between classes, the that way you are able to sustain the code for a longer period of time. If there are a particular class is getting called in many different places, it becomes harder to manage. And one of the examples that I would say is the use of utils class. If you know that, not utils class, but utils. Basically, what you do is you put a uh, you'll have a lot of classes code where I don't know whether I've done it or not. Okay, it doesn't have this one, uh, but um, yeah, you will have certain times you will create this kind of a thing. Package. They'll call it utils, and then that would be a static class. Uh, and the final- I don't know
And
why-
this
yeah,
by and will be called many places.
yeah, and then you will have certain methods. Say public local date time, local time, maybe something like that. And then this gets called in across the code at different places. And what that would do is that, because it will be a global thing, basically we just create a global, I don't know why it's getting, whatever, okay, I'll just put it on like that. But this will be a you can put a starting here. Yeah, and it would just it can get called anywhere and everywhere. And then what happens is that anybody, if somebody wants to go and change the logic, you just can't do it, because it's used in 100 places, and there is no way you can go and change at 100 places to do it. So what yeah, that code just get yeah, that will stay in that source code for like maybe 10 years or 20 years, whatever the lifetime of that particular repository is. Nobody will go and update it. They can't do it. It's just going to stay in there for the what are the duration of the time. So that's one of the examples where you try to ensure that you don't use it. But this is a pattern that everybody is being using it. But what you have to ensure is, like, if you are trying to add something in this kind of an utils class, or you're making something static, just be sure that you really need it. Because if you are not sure, and you just some people just go on adding stuff in the util class, and then yeah, it becomes very hard to change. So yeah, we would want to just ensure that whatever we need, we just put it in the whatever business logic class or something like that, where it's much local. So if something has to change, you can easily go and change it at any point of time. So, so that's one of the examples of it. I think I put in some more examples.
What what makes it immutable? That it's a utility or that it is a public static class?
It is public static, and it's being used at many places.
Okay, so just that principle means you
Yeah,
shouldn't change it. Okay.
yeah. So because if it is used now, this is a very simple thing, but if there's a bit of complex logic inside it, um, I mean, most developers will be afraid to touch that. They'll just simply either create a new method if they want to, you know, may use a simpler method, or they have to change the logic. They'll just use a different method, and then they will use it in their own particular class. But this code will they will not touch it, and then that just keeps on adding fat to your code, which is
Mhm.
not required. Okay. And then this one, yeah. So the key things that an object should call method of its own class. So yeah, if your class A has got a B, you can kind of it just uses its own variables instead of using something else. So that's one. I think there's one more example. Yeah, avoid chaining of methods. Yeah, you have this kind of a code. You'll find this kind of a code a lot of places, like B got get C and dot get D. You don't want to do that. What you would typically do is, like, uh, C, uh, C might have a variable of D, and then C will have a public method, which will in turn call D and calculate the result for you. So that when you call it from B, or the other way around, right? You can put it in B, which will directly call D. Within B, you will have a method which will call class D, and it will get you the result for you. And then from your perspective, you are just calling one method of D. So instead of chaining it, you just kind of short circuit it. That because the problem is that the same problem that any of these classes change, like C changes some implementation or D changes some of its implementation, yeah, the whole chain breaks, and it kind of cause a lot of problems. The good part of this problem is that the compiler will tell you that there's a problem here. But then when compiler tells you the problem, yeah, you will kind of yeah, you will say who did this, and then you have to kind of refactor the entire piece of code for because somebody else did this kind of a chaining thing. So you just want to avoid this chaining method calls. Yeah, you can just kind of create more noise. Uh,
So that refers back to object should call method of its own class, and that you
yep,
define your private variables within the class, and the method that you build should use the variables from within its own class instead of using other methods from other classes.
that's correct.
Okay. Keep them as separate as you kind of can
Yep.
and self-sufficient. Okay.
Yep. And what one of the other things that even if if you are writing unit tests, right?
Mhm.
There's another way of finding if you're causing some problem with. I mean, if you're breaking the law of Demeter, is that if you write unit tests, and if the when you write unit test for say class A, what you'll have to do is you have to kind of mock class D and
Mm.
mock the result of class calculator, you also have to mock some part of get C to get it. So what that means is that the number of mocks will start increasing.
Yeah.
So that should kind of raise a flag for you, saying, you know what, if there's so many mocks that I'm using, which means I have my test is not or my class is not modular or it's not independent. There are a lot of more dependencies around it. So you can, from that perspective, you can go and and the best part of writing tests is like you write the test and then you start playing around with your, you can refactor your classes, and then you kind of you know you do it iteratively, like update your class and then test, update class, test, and then you can kind of refactor it pretty quickly.
Mhm.
But though writing those tests, sometimes what happens is because we are very deep in the code, we might make this mistake unknowingly. But when you go and start writing the test, that time these kind of things pop out. Okay, you know what, I can make it better, kind of a thing. So that's another way of not making a mistake. Like, yeah. Third is again similar to the first one. So instead of the class, so in the method, if you're passing, you just pass necessary information uh, or parameters. Yes. So sometimes what we do is we pass the entire object, and that's not required. For example, there might 10 field in an object. You might only need two or three. So you better to pass those parameters rather than passing that whole object around and playing around. That's one small way of avoiding complexity, because people will know when they see the method, they see the three things that are being passed. It's much easier to comprehend that three things rather than if they see the whole object getting passed and then they don't know what all things are being used, and then they have to read the entire code just to figure out, okay, only three things are being used. So so that comes into the place where in the object you have 10 fields and then you're going to delete one field. You don't need one field. But then if you want to figure out which field has to be whether there will be a problem in any other piece of code, it will be very hard if you are going to pass around the entire object.
Yeah.
uh, yeah, I think this we talked about hybrids. So we we don't want to add business logic in data classes, because if you add business logic in data classes, it will just your logic is sitting everywhere. You have your service classes where your logic should be there, and then if you put in data classes, yeah, it will just complicate things. And then what you have to do is like other thing is like from a unit test, you generally, if it's a data class, you don't need to test your data class, because what it has is it only has got getters and setters in it. It doesn't have anything else. But if you start adding business logic, which means you kind of have to write unit test for a data class as well. And then that's a big red flag. Okay, you know what? You're mixing data and the business logic. Just keep it separate. Um, yeah. The last one is on data transfer objects. Yeah. So you use the data transfer objects for mapping objects between two systems. So for example, system A or system A can be even a class A. Will may have like 10 fields, and the class B or system B will only need say 5 fields of it. And then sometimes there is a mapping logics around it. For example, a system A might be using the date time in a string format, but system B who may not be using it in a string format. They might be using a basically a date time object. So yeah, those kind of a thing you kind of do using this data transfer objects. And the second part, and then there is a other way that you can use a data transfer object is in terms of maintaining a state of a process. So I've kind of used it here. Did it go? Uh, so yeah, this DTO stands for data transfer object, and then I receive a file. It's a job, and I need to process that particular file. So I just update this DTO file, and then each of these operations may or say for example file process D2, it will go and update the update file status. So all the operations it will do using this data transfer object, so that data transfer object then now maintains that state of this particular process. And what that does is the whole thing becomes very easier to read and understand as to what's happening. The entire process becomes easier, and all the whatever the inner workings of these methods, they are encapsulated in this different methods. So yeah, that's one way of having using the data transfer objects for yourself. um, and yeah, the last bit is about active record. Now this was a pattern that I used to use, I mean, few years back, but I no longer use it. So what we would do is we have entity objects like this, and then we'll create a very same record object or active record object. So what we do is you just do a uh, you do that, and you remove all the yeah, you just remove all the database related thing. It's just a same class, but it's now not an entity object. It's just a simple object. And what we would do is like we would get the data from this queue entity, and then we map it to this file queue record. And if there are any in-flight operations, which means like I want to do something with this, in that scenario, I would kind of map into this record and will do using this object. And then finally, when I have to save it, I will then again map it back to the entity object, and then save it using the entity object into the database. Now the problem with this is one, I'm adding additional code. This is a redundant code, right? It's not actually required. It's just being used for some mapping, and then again mapping it, return it back. The other thing is like then people what they start doing is then they will start adding helper methods within this particular class, which means then it will start messing up with the adding more business logic into this particular class, and then it just blows over. Like then again we go into that hybrid class scenarios. So yeah, I mean personally for me, yeah, that's the thing that developers start adding business logic to it. Yeah, I don't do it anymore. I mean, it was a pattern that we used to do when we're using this EJBs and things, but in the current world, not using it anymore.
So generally speaking, to keep data concerns and business logic concerns separate, you would then put that helper function into the service directory, which
Yeah, it
yeah.
will be there in a services, like because this is like one of the things where Spring Boot tells you that you know what, put the business logic in the service directory. That's why we are doing it. Yeah, but if whatever framework you are using has a different concept or construct, you kind of use in that uh, manner.
But generally there's a home for business
Yeah,
logic separate from, and when we talk about data objects, that's the private variable get and set.
yeah, you have these models, right? We
models.
again call it as models where all the data structures or data things are there.
And sorry, what's the biggest distinction again between a an entity is a subfolder within a model. So can we go over that just a little bit? What is an entity specifically for?
It is the object which is directly mapped to a database object.
Okay.
So you see that UUID and I just say generated value. Like this is again a bit of Spring in it, saying that it will generate automatically for you. So what happens is like if I have to save a new object, a new row to a database, I just fill these fields, but I will not build a ID. And when I click on, I do a save entity, At that time, the Spring in the background generates a UUID for me,
Mhm.
and then saves it, and then it will ensure that the UUID is unique and everything. I don't need to. I mean, from a developer perspective, developer does not have to do it. So that's why we kind of use this entity objects.
Got it.
Yeah.
And forgive this if I'm like taking ideas from not relevant places, but is this connected to like object relational mapping kind of a thing? It's like
Yeah. ORM. Yeah. The entity yeah, that's underneath you have an ORM. So Spring uses Hibernate.
Mhm.
So yeah, it will using the uh, object relational mapping to do this
Okay.
work. All right. I think I'm done. Yeah. Any other thoughts?
Um, sorry. So I found a PDF of the book. So I just want to see where are we relative to what we talked about last time.
We are on chapter 6.
Right. Objects and data structures. And then last time was formatting.
Yep, that was number 5. Yeah. So we're
Okay.
just going like sequentially on that one.
Okay. That's right. Okay.
All right. Fair enough. All right. I think. Hey, Maxim, you have any thoughts?
No.
Uh, all good. Then I'll close this call. Thanks for joining.
Okay.
Yeah. Thank you.
Thank you.
Yeah. Have a good weekend. Yeah.
Have a
Bye.
good day, guys. Bye.